Hey everybody, this is Larry. This is March 20th in the year 2024, which is kind of crazy. I started this, I didn't start, I just started this channel a bit before that, but I didn't really actively use it daily until like April of 2020, which is pandemic. So it's kind of crazy that that's been a couple of years. Anyway, but this is my RNG video of me just getting a random problem and let's solve it. Today's Larry RNG problem is the bonus problem, as I like to call it, is 396 rotate function. So give an integer array nums of length n, assume array sub k, array sub k, okay, to be the array obtained by rotating nums by k position clockwise. I always get these wrong which way it is, but I guess we'll see. We define the rotation on nums as equal to this thing. What? Say what? Oh. So 0 times. Huh? Alright. Let's look at an example. Okay, f sub 0 is equal to. Oh, okay. Oh, f sub k is. Oh, this is the same k. I see. And then you're trying to get the 0. Okay, so then the 0 of all these things. I'm double checking on the n's because if n is like 100, then it's easy, right? But it doesn't seem to be the case. Or like, it probably is. I'm not saying that's hard otherwise, but why use brain power if you don't have to? You know. Look, I'm getting old. I don't have many brain cells, so I'm trying to save the ones that I do have. But okay. So 0 times this, 1 times the next number, and then the next one is going to actually shifts the other way. So this is actually 1, this is 2, this is 3, and then we lose this one. I mean, I think the way to kind of think about these ones is, I think I said the same thing yesterday or the day before, but I mean, you know, this is a very common idea, but basically the idea here is that you know, instead of writing it like this, which to be honest I think they try very hard to hide it a little bit, instead of writing it like this, actually I could just copy and paste all three, I suppose, right, which you're like, okay, well, I mean, that's interesting maybe, but how can I use this to is that you actually shift them so that they kind of line up, right? Something like that. This is a little bit manual work. Give me a second. Or you can fast forward because you're at home, and I cannot fast forward my time. I guess I could if I just skip ahead, but I like, you know, we're doing it live here. It is the name of the channel. Alright, so something like this, right? And then it should be clear what's going on, right? Basically, from F0 to F1, what happens? Well, we add 4 plus 3 plus 2, and then we minus n minus 1 times 6 or whatever, right? So, and then the next one, we add again 4 plus 3 plus 6, but then we subtract n minus 1 times 2, and then so forth. And then we just do it n times and we should be good, in theory, right? So yeah. Yeah, it's a little bit awkward, but it should be doable. I mean, you know, yeah. So then maybe we can just say f0 is equal to 0, right? For n is length of nums for I in range of n, right? Then f0 we add it by I times nums of I, right? Okay, so then now we have f0. Right, and maybe we you know, keep track of max. Can it be negative? It could be negative, so I guess we have to be careful and maybe just do it to negative infinity, right? And then now maybe we have like a total is equal to sum of nums, right? And maybe just for, I don't know, whatever sake, we're here for parallel reasons, right? And basically, yeah, every from f, because as I said, okay, so f1 is just equal to f0 plus, and I said it in a weird way, but you could actually say, because I said it in that you could add 4 times 3 times 2 and then subtract by n minus 1, which is 3 times 6, right? I mean, that's kind of, you go down. But now that I see it, and did I write this wrong? I think I wrote this wrong. This is addition. Sorry. 3 times 6 is the multiplication. But now that I'm looking at like this, actually you could even reduce this to be even more. I mean, you could actually, this is actually enough to solve. You just have to be careful, but this is enough to solve. But actually the way that I want to write it now is then now we add the number 6 on both sides, right? On here, or we add 6 and then we subtract 6, then you get this, right? Then what is this? This is just total, because this is every number, and then this is now n times what is it? Nums of n minus I, right? Or n minus, I guess n minus I, right? Which is in this case n minus 1, right? The last element. And that's it, right? So then now, and of course f of 2 is a similar thing, right? F of 1 plus total minus n times nums of n minus 2. And that's it. And this is a way easier formula. Well, I mean, okay, relatively easier formula to not make a mistake on. So then let's do that. So then now we range from 1 to n, right? Well, I guess n is exclusive, but you know what I mean. And then f is equal to let's say last f is equal to f0, right? And we also have to say best is equal to max best f0, which is fine, right? And then now f is equal to the last f plus total minus n times num sub n minus I, right? As we said, I always like parens just for, I mean, I know all about it, right? And that's pretty much it. And then we just try to max it again, and then last f is equal to f, and then we just return best, and that's it, I think. Yeah, I always forget to click on the use example case on the old UI. I think the new UI, they just default do it for you, right? So yeah. Yeah, looks pretty good, and there you go. Yeah, it's a cute problem. But yeah, we'll submit it again. So I don't, just to get rid of the header a little bit, I suppose, for future's sake. I don't know, it doesn't really matter that much. But yeah, as you can see, this is linear time, constant space. We only have like 1, 2, 3, 4, 5, 6, 7 variables or something like this. Whatever it is, it is constant. And yeah, hope this makes sense. I think this is a cute problem, and this is a very good practice problem, I think. Because I think this is, because not necessarily like the exact thing, because like how often do you get the exact problem, but this idea of just like taking the delta, like almost like a sweep line or incremental updates or whatever you want to call it. This idea comes up a lot, and trying to figure out how to calculate the delta in a faster time then allows you to do it in linear time, or sometimes if your update is log n, then it's n log n, right? So yeah, yeah, that's all I have for this one. Let me know what you think. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.